EMP, every nation's nightmare. This is a scenario in which we can only contemplate, that we can only theorize about. Although the possible effects are known and mathematically defined, the actual result of a large-scale EMP is still somewhat of a mystery. An electromagnetic pulse is a burst of electromagnetic radiation that results from the detonation of a nuclear weapon and/or a sudden fluctuation of the Earth's magnetic field. The resulting rapidly changing electric fields and magnetic fields couple with electric systems to produce damaging current and voltage surges to power systems, electronics, and information systems. These in turn can seriously impact other important aspects of life. Because of our dependence on electrical power system, its vulnerability to an EMP attack creates the possibility of long-term devastating consequences. A single EMP attack may seriously degrade or shut down a large part of the power grid in the geographic area of the EMP instantaneously. There's also a possibility of functional collapse of grids beyond the exposed area as electrical effects propagate from one region to the other. The E1 pulse, E2, and E3 pulse. The E1 pulse is the early time portion of the EMP, and it arrives at the Earth's surface quickly and lasts about 1 microsecond. It's a fast spike, and its energy is concentrated in the frequency band between 1 to several hundred megahertz. This is a free field energy pulse with a rise time measured in the range of a fraction of a billionth to a few billionths of a second. It is the electromagnetic shock that disrupts or damages electronics-based control systems, communication systems, protective systems, computers, and similar devices. Its damage or functional disruption occurs almost simultaneously over a very large area. The E2 pulse is the intermediate portion of the EMP and covers between 1 microsecond and 0.1 seconds. Its frequency band is between 1 Hz and 100 kilohertz. This middle time component covers roughly the same geographic area as the first component and is similar to a lightning strike, but is far more geographically widespread in its character and somewhat lower in amplitude. In general, it would not be an issue for critical infrastructure systems since they have existing protective measures for defense against occasional lightning strikes. The most significant risk is synergistic, because the E2 component follows a small fraction of a second after the first component's impact. The first component has the ability to impair or destroy the protective and control features of our grid. The energy associated with the second component will then pass into and damage systems further. The E3 pulse is the late time portion of the EMP and occurs between 0.1 seconds and several minutes. This pulse is characterized as a low amplitude, very low frequency signal. This final major component of the EMP is a subsequent slower rising, longer duration pulse that creates disruptive currents in long electricity transmission lines, resulting in damage to electrical supply and distribution systems connected to those lines. The sequence of the E1, E2, and then E3 components of EMP is important because each can cause damage, and the later damage can be increased as a result of the earlier damage. About 70% of the total electrical power load of the United States may be exposed to an EMP event. Determining the range of effects. For equipment to be affected, the weapon needs to be above the visual horizon or the curvature of the Earth. Because of the nature of the pulse, it's doubtful that there would be much protection if the explosion were seen in the sky. The area covered by an EMP is dependent on the altitude of the detonation and the yield of the weapon. Assuming a yield of sufficient strength, 1 megaton or more, the ground coverage can be estimated from this following formula, where RT equals the radius of the affected area in miles, RE is the average radius of the Earth in kilometers, assumed to be 6,370 kilometers, HOB is the height of blast in kilometers, cosine minus 1 is the arc cosine in radians, and note that this equation is in radians. Devices that will be affected. The first, of course, is the power grid, which in turn will have a cumulative effect on everything else. The electrical power system is the largest single piece of infrastructure in North America. It is this vast array of systems and components all acting in concert, integrated into a cohesive whole to deliver electrical power at the point of use. Major components in the electric power infrastructure. There are three major elements of the electrical power grid. These are the generation, transmission, and distribution. These elements are all dependent on each other, yet distinct in their purpose. Generation. In most circumstances, the first stage of generation converts the original form of energy into rotational mechanical energy that turns a turbine. The turbine then drives a generator. Transmission. The electrical power from the various power plants travels over a system of lines and substations to various regions. Transmission includes lines, wires strung from insulator strings on towers or underground in special insulated containers, and substations, the points where several lines intersect and protection and control functions are implemented. With substations, there are transformers, breakers, protective devices, meters, and data transmitting and control systems. Protective devices protect the electrical components from unusual electrical disturbances that occur from time to time for many different reasons. Distribution. Load or end users of electricity require electrical power to be available in the voltages needed in adequate supply when they need it. This often means in relatively small quantities at low voltage or current. The size of the wires and switches in a typical house are able to be quite small because the power available to that house is restricted to be relatively low. The electrical and electronic appliances similarly need only a small amount of power to be available. Therefore, the high voltage power of the transmission system is reduced or stepped down through the use of transformers and distributed to the end users in levels they need and can use. The control system. The control and protective systems. Overlaid on all three of these primary elements, generation, transmission, and distribution, is a control system that directs the power where it's needed, maintains the frequency, and protects the system. The controls must protect the system from transients such as lightning, correct synchronization errors by activating reactive sources or loads, isolate malfunctioning elements of the grid, and prevent self-damage from improper compensation or human error. These are highly susceptible to the E1 pulse, resulting in degradation of control and protective systems, making the entire system more vulnerable to the following E2 and especially E3 pulse. The integrated electrical power system of the United States and integrated systems in Canada and Mexico is broken into only three truly separate systems at the present time: the Eastern Interconnection, the Western Interconnection, and Texas. The dividing line geographically between the Eastern and Western systems is roughly between Montana and North Dakota, continuing southward. The largest of these, the Eastern Interconnection, serves roughly 70% of the electrical load and population of the United States. The three regions are separated electrically in order to provide barriers for transfer of major frequency deviations associated with system separations. This mode of operation between regions is referred to as maintaining frequency independence. Importantly, this also acts as a barrier to EMP-caused system disruption and any other major system disruption and collapse crossing between these three regions. This is one reason it's theorized it would take 3 EMPs detonated above the United States to take down our entire power grid. Medical devices. Medical devices such as pacemakers and insulin pumps. For those with portable or internal devices such as these, then the situation is much more concerning, because without proper shielding, these devices will most likely fail. Other medical devices are dialysis machines, hospital equipment. The medical devices will be affected immediately. Modern electronics, such as computers, TVs, modern radios, anything with an electronic circuit controlled by an IC using solid-state technology is highly susceptible to the EMP, especially if these devices are plugged in to the outlet. Some of the services that will be lost immediately: telecommunications. When the grid goes down, communications will be the first to go, followed quickly by banking. Our banking systems, with a lack of power and having their servers and their computers basically fried, then most people are going to lose everything that they had in the bank and in any type of investment that they may have owned. And this would include your 401ks and any stock market investments. an immediate grid down situation, which will result in a chain reaction of vehicle accidents to begin with, and this will be due to some of the vehicles stalling, to traffic lights failing, and other traffic indicators failing. It doesn't take an entire highway of vehicles that are damaged by the EMP. It only takes a few to stop traffic indefinitely. Broadcasting and news services will end immediately. Internet access. And this is going to be a very difficult situation for a lot of people, because losing all of the conveniences we have at the touch of our fingertips. I can go to the faucet and turn the water on. I flip a light switch, the lights come on, and these services will not be there, just thrusting us back into the 1800s, literally in the blink of an eye. Transportation. And this is referring to public transportation. Public transportation will fail immediately with the electric train cars, electric buses, and systems like that. Public utilities. Of course, with public utilities, the first thing we lose is the electricity. But some larger facilities, when it comes to the water aspect, require power to pump the water from one location to the other. When we lose power to pump the water, then we lose access to water. Medical facilities will be damaged immediately. Although they do have backup generators for the most part, it's the devices inside that fail that are going to make the facilities basically useless, with the exception of the people who are still in there that have the knowledge they have. Police, fire, and emergency services. I expect these to remain in place at least for a little while in the beginning. But with a loss of communications, it's going to make it very difficult for these services to coordinate with one another, and with loss of water pressure soon behind it, the fires are not going to be able to be put out. Grocery stores will close immediately. Even stores with backup power supplies will have to close due to the fact that the grid is down elsewhere, and they will not be able to communicate with any of the banking systems to verify purchases, so these will close immediately. Gas stations will do the same thing. Without any power, gas stations will close immediately due to the inability to pump gas. With the loss of these services, we can expect civil unrest, riots, looting, and burning. Fires will rage out of control without services to fight them. Crime will be rampant, as there will appear to be no consequences of this now. Stores will be emptied within the first few hours or days at the latest. The streets will become a dangerous and even deadly place with little to no law enforcement. We will be left to protect and defend ourselves with only the things we have. Lastly, we could expect to see the country that enacted the EMP attack to quite possibly follow with a nuclear attack or a military invasion. Devices that could survive. Remember, a large portion of the survivability of these items will actually depend on whether or not they are connected to the power grid, or basically plugged in at the moment of the EMP. Of course, mechanical devices. Mechanical devices will survive because they have no electronics or electrical devices within them to damage from the EMP. Analog devices like watches and clocks. Satellites. Some may not think that satellites will survive, but satellites in high Earth orbit have a very good chance of survival. And the reason for this is because outside of the Earth's atmosphere, there is no atmosphere for an electrical current to travel across. So it is only the gamma rays and X-rays that these satellites will be bombarded with from the EMP. Most satellites are already shielded to protect themselves against this type of radiation due to the fact that they are constantly bombarded with this type of radiation from the sun. So if a satellite is not within the range of the blast itself, then there's a very good chance the satellite will survive. Which means in turn, any satellite devices we have that still have a power source of some type and were protected from the initial EMP would allow some means of communication for some people. Older electrical devices, such as devices that use vacuum tubes or even shielded electrical or electronic components, will survive. The older electrical devices tend to be more robust than the ones that are produced today and stand a better chance of survival. The best thing to do with any electrical or electronic devices, if there is any forewarning of the EMP, is to unplug everything from the walls. Unplug everything. Cell phones. Depending on which source you read, some say that cell phones will survive intact through the event, especially if they are not plugged in or charging to the wall. If these devices do survive, we still have the fact that we have no communication towers, no relays. we would have no cell service. So they could function as devices if we had something stored on them, but as far as using them as a means of communication would not be possible. Cars. Studies show that cars without electronics would survive, but studies have also shown that newer vehicles stand an approximate 85 to 90% chance of overall survival. Some damage may occur, but the overall functionality will still be there. There are two tests we'll talk about here, and a direct quote from their test. We tested a sample of 37 cars in an EMP simulation laboratory with automobile vintages ranging from 1986 through 2002. Automobiles of these vintages include extensive electronics and represent a significant fraction of autos on the road today. The testing was conducted by exposing running and non-running automobiles to sequentially increasing EMP field intensities. If anomalous response, either temporary or permanent, was observed, the testing of that particular automobile was stopped. If no response was observed, the testing was continued up to the field intensity limits of the simulation capability, which was approximately 50 kilovolts per meter. Automobiles were subjected to EMP environments under both engine turned off and engine turned on conditions. No effects were subsequently observed in those automobiles that were not turned on during EMP exposure. The most serious effect observed on running automobiles was that the motors in 3 cars stopped at field strengths of approximately 30 kilovolts per meter or above. In an actual EMP exposure, these vehicles would glide to a stop and require the driver to restart them. Electronics in the dashboard of one automobile was damaged and required repair. Other effects were relatively minor. 25 automobiles exhibited malfunctions that can be considered only a nuisance, like blinking dashboard lights, and these did not require driver intervention to correct. 8 of the 37 cars tested did not exhibit any response. Based on the test results, we expect few automobile effects at EMP field levels below or 25 kilovolts per meter. Approximately 10% or more of the automobiles exposed to higher field levels may experience serious EMP effects, including engine stall, but this would simply require the driver to restart the engine. Additionally, a 2004 study by the U.S. EMP Commission came to the conclusion that in the event of an EMP, approximately 10% of the vehicles on the road will stop. The common standard used was 2002 to 2004 vehicles as the newest vehicles tested. Although any vehicle from approximately 1994 do have electronic sensors, controls, and similar, these could be affected, but multiple studies say the majority will survive, at least enough to still provide transportation. After 2004, vehicles have become much more complex, and there have not been any reliable studies made public about this. Electric vehicles are expected to fail completely. Solar panels will survive. Solar panels will still work, but expect a decrease in performance, maybe 10 to 15%, but the control systems for these may be damaged and may require replacement. Batteries. Most batteries can survive an EMP of any magnitude without suffering damage. This is true for all common types of batteries, including lead acid, lithium-ion, alkaline, and nickel metal hydride. Only complex battery modules with built-in charge controllers are likely to be affected. For the most part, batteries are their own little Faraday cages. Their outer portion is metal, and there are no wires or circuits inside to fry. Problem is, most of us have become so dependent on electronics that almost nothing is powered by conventional batteries anymore. Many of our devices that have battery backups also have circuit boards and microchips. Batteries alone should be fine, but modern devices with batteries inside them may need protection. How to protect devices. The most common means to protect a device from an EMP is called a Faraday cage. A Faraday cage is named for the 19th century inventor Michael Faraday, and it's any conductive structure that protects its contents from electrical pulses. Your simplest option is a tightly sealed metal garbage can. Other options can include an ammo can or a metal safe. A Faraday cage is easy to build, but since we do not know the exact level of damage that can be caused by a weaponized EMP, it's impossible to truly say what electronics may survive. And here we'll look at how to build a Faraday cage using a metal trash can, a plastic trash can, and a piece of wood. One of the simplest and most effective Faraday cages that can be built is using a plastic trash can within a metal trash can. To begin with, obtain a plastic trash can such as this and a metal trash can. Cut the handles off the plastic trash can so it'll fit inside the metal trash can. Place the plastic can inside the metal can. Then cut the handles off the lid for the plastic trash can. Cut holes in the lid to make rope handles or some type of makeshift handles that you can remove the lid with, because it will be difficult once it's fit inside of the metal can. Next, place a block of wood in the bottom of the trash can. Then place your devices in a cardboard box or some type of similar container and insert those into the trash can. Then put the plastic lid on the plastic trash can. Then finish the process by putting the metal lid on the metal trash can. Make sure the seal is good. For an additional measure of protection, you can dig a hole and place the entire assembly in the hole, placing your devices inside, then placing the lids on top, and then covering it. This is possibly the most protection you can get from a homemade Faraday cage. This is a theory, it is not mine, but I will present it. For those with electronic implants, it is theorized that a homemade Faraday cage can keep you safe in this type of situation. And here are some examples of other types of Faraday cages. And there are some links in the description below to assist anyone in building these types of cages. You can use anything from chicken wire to aluminum foil. And the materials that tend to make the best conductors are copper, aluminum, and silver. Microwaves are also rumored to work. There are many commercial products available that can protect devices or claim they can protect devices from EMP surge, and these are very pricey for the most part. Things we can do to prepare. Basic survival skills are always a must. And for the prepper community, I would safe to say that most people have developed their basic survival skills, or at least understand them and have developed them well enough to survive in a difficult situation. Plan to escape. In urban areas, the need to bug out may come very rapidly. It may be during the onset of the event or maybe 24 to 48 hours after the event. But in any situation, having a plan ahead of time is going to enable you to more safely bug out of that area and give you the best opportunity for you and your family to escape a dangerous situation. Have bug out gear. Along with the bug out plan, you're going to need gear to help get you out of the city and help you survive in any type of wilderness or rural situation. And having the appropriate bug out gear can make the difference between life and death. There are many videos on the internet and some on my channel that cover bug out gear in great detail. Books. Have books on all topics, because if our computers and if our cell phones and our tablets are gone, then all of the information in our PDFs and files such as that on survival, on edible plants, is gone. Without hard copies of these topics, then in the end we're going to be at a loss. Have books and maps on your general area, books on edible plants, medicinal plants, first aid, any types of books that would assist you and your family in survival. Another need is first aid gear and knowledge. And this is going to be very important due to the fact that most medical facilities will be closed down almost immediately, and they probably won't be able to accept any new patients, especially for minor injuries, cuts, or even broken bones. Having the ability to treat these types of injuries and having the knowledge to do so will not only save your life or your family's life, but could aid in someone else's survival, thus making you an ally. Which brings us to the next section. Have a group, friends, or family. Group survival will be much easier than lone survival. And when we talk about lone survival, I'm talking about even just 2 or 3 people. The more people you have that can work together and that can help provide, the safer you will be, especially when it comes to the security aspect. Have food and water and means of water purification. A supply of food is the backbone of prepping. That's one of the most important things we can have, along with water. Without those 2 things, nothing else is really going to matter, because you're not going to last very long. It's better to have closer to a year if you can, but not just the food, the water, and the purification. There has to be a means to prepare this. There has to be a means to prepare the food without power, just in case there is no power, just in case there is no solar energy that we can use. And that's why a wood stove would be an excellent investment. And small hand-powered mixers, hand-powered can openers, manual devices, other kitchen devices that are normally powered now, but that you can get manual alternatives of, will only benefit you in the long term. Be prepared to hunt, fish, and grow your own food. As the event stretches out, as time goes by, then the supplies that we have stockpiled, the supplies that we have prepped, at some point in time will run out. And the need to hunt, fish, and definitely grow your own food will become painfully obvious at that point in time. So having these abilities now is something that will only better prepare us for the future. Have a means to generate power. Solar power will be one of the most efficient and easiest to use because solar panels won't be damaged by an EMP. And these are fairly cheap and inexpensive, at least the smaller ones, so we can power lights or small devices such as that. Communications. And this would go back to the Faraday cage or securing your electronics too. Communications are going to be extremely necessary. Not that everyone will have them, but having small handheld radios that can at least broadcast the emergency broadcast system and can at least get the weather stations and things such as that, so that if any part of the grid is still up and running, because some areas will be, not everything will be taken out. And having a means of communication will allow you to know what's going on around you and will make it safer to traverse from one location to the next. A set of basic tools, and these are tools for the basics of home repair, possibly mechanical repair, or for building and repairing fencing and securing around your home. These are very important because if we don't have a set of tools and the time comes, it's not like we're going to be able to go out to the hardware store and pick up a set. Have a means to dispose of waste, human waste especially. This is a subject that doesn't get talked about as much, and this can be extremely difficult for people in a very crowded urban area. What can we do with the human waste? Now, this is going to be a very different situation for everybody out there depending on where you live. But there's something else we must consider too, and this is something no one talks about. What do we do with those who pass away during this? In urban areas, this will be a problem as there's simply not enough area for burials. And as difficult as this sounds, you must put some thought into this, as it will, without a doubt, happen to everyone at some point. We will be faced with this. Self-defense and defense of your home. Self-defense and defense of your home are two of the preps that we will have to have in place, and we have to be mentally prepared to enact these preps. Self-defense in the aftermath of an EMP is going to be extremely important because as the services fail, people will come, and not all of these people are going to be looking to barter or trade. A lot of these people are going to be looking to take, to kill, to steal. And that's just the simple fact of life. That's just simply human nature for some people. And we have to be prepared for this. So having a means of self-defense is one of the most important aspects on here. Lighting, and lighting could be tied into the solar power we mentioned earlier, but flashlights and batteries, these devices will survive an EMP. Candles. Oil lamp, and for oil lamps, the lamp oils you could use are non-dyed kerosene, the clean heat kerosene substitute, your standard clear lamp oil, homemade lamp oil, and for outdoor use, the citronella oil. And these are things that we could put back and could keep a decent amount of to help us in the initial stages of a grid down. But keep in mind that even the light from a single candle can be seen a long distance away. Ensure your shelter or home is protected against light from escaping, or basically ensure that all windows and openings are covered and any lighting used within cannot be visibly seen from the exterior. Transportation. Even if your vehicle works, the supply of gasoline is limited, especially with the grid down and no more production activities. Having an alternate means of transportation will be necessary. A bicycle or even a horse. Other means may also survive an EMP, such as older off-road dirt bikes and older four-wheelers. But once again, the limitations of fuel will apply to these. Barter items. Barter items will enable you to trade for supplies you need and also basically can enable you to make allies along the way. In an EMP scenario, I think money will be worthless because this is going to be a scenario that most people realize it will be long term. So the best barter items, that we're going to be looking at, everyone's going to be trading for food. So anything in the first aid category, anything in the food category, the water or water purification, skills can be barter items. But keep in mind that barter will be the new form of finance once an EMP does hit, at least on the local level. And lastly, be prepared and accept the fact that if this does happen, then our now new normal just became something different, something that will not pass quickly, and something we will be faced with surviving for possibly years. those were a lot of effects, a lot of preps we can make, and things we should take into consideration when considering the EMP as something we're prepping for. I hope the video was informative. Thanks a lot for watching. God bless. And for now, Seer Survivor, out.